Now let us see the design of FIR filter, that is symmetric and antisymmetric FIR filters. Well, we are going to find the digital filter, symmetric and antisymmetric FIR filter. First, we want to see about what is the digital filter. It is just a filter that operates on the digital filters, digital signals. And in the case of FIR filters, the FIR digital filters is designed using finite number of responses, that is coefficient is called the finite impulse response, that is response filters, that is h of 0 up to h of n minus 1 into n. And the linear phase FIR filter, a linear phase FIR filter is a unit sample response satisfying the condition h of n equal to plus or minus h of m minus 1 minus n, therefore n equal to 0, 1, 2 up to n minus 1. Now, that is in the case of symmetric and antisymmetric, we are having four cases: symmetric, odd, even, antisymmetric, odd, and even. First, we can see about the symmetric impulse response for n odd. The frequency response of the impulse response can be written as h of FIR j omega, that is summation equals 0 to m minus 3 minus by 2. That is, we are splitting in terms of 3 equation. After splitting, we are just applying the condition n equal to m minus 1 minus m, and where we are substituting z equal to FIR j omega. Therefore, it is marked as equation 2. Here we are substituting that h of n equal to h of m minus 1 minus 1. After substituting the equation, we are reducing the equation, and finally we are finding the pole, and that is we are finding the magnitude and pole. Therefore, the magnitude response and the phase response is given as shown in the screen. Next one is symmetric impulse response for n even. Here also in the case of even, we are splitting the equation into 2. After finally splitting the equation, we are into 2. We are substituting n equal to m minus 1 minus n and z equal to FIR j omega. And here after finding the equation, we are substituting this. We are marked this as 2. And the case of symmetric impulse response, h of n equal to h of m minus 1 minus m. Here we are substituting the equation, and finally we are finding the value, and after that we are finding the value for the magnitude and phase. It is shown this the magnitude and the phase angle. It is shown for n even. Next one is antisymmetric n for n odd. In the case of antisymmetric filter, the middle term is equal to 0. We are taking the middle term as 0. Therefore, h of m minus 1 by 2 equal to 0. Therefore, we are getting this equation, and we are splitting this equation, and we are applying this antisymmetric condition, h of n equal to minus of h of m minus 1 minus n. Therefore, after applying this symmetric condition, we are finding the values, and after finally we are simplifying, we are finding the magnitude and phase. And last one is antisymmetric for n even. In this case also n even, here we are splitting this into 2 equation, and the equation is written in such a way that h of n equal to minus of h of m minus 1 minus 1. That is the condition for antisymmetric FIR filter. After that, we are substituting z equal to FIR j omega, and we are simplifying, and finally after simplifying, we are getting the value for magnitude and phase. That's about the symmetric and antisymmetric FIR filter. Thank you.